Sri Gurubhyo Namaha children, welcome to our online teaching academy Ekalaiva. Today we are going to talk about class 10 electricity. In our previous class we have learned about Ohm's law and as well as resistance and resistivity. Today I am going to talk about the topic resistance of a system of series, system of resistors. So, how can be these resistors can be connected in a system? We will get into the topic. Resistors are joined in two ways. One is the series and the other one is parallel. One is the series and the other one is parallel. Already you know what is resistor. Resistor is a component which resists the flow of electric current or otherwise resist the flow of electric charge. And usually resistors will be looks like this, and this can be called as carbon resistors, and these colors indicates the rate of that particular component, how much resistance it has. And these things you will be learning about in our previous next class. And now we will talk about the resistor. You know what is resistance? Resistance means the component or otherwise a particular conductor will resist the flow of charge. Am I right? Yes. Yes. So, we know that what is resistor now. Suppose if we connected two resistors in case of a series or in case of a parallel, what will happen to the total resistance? That is what we are going to discuss, and in today's topic we are going to see only the series. So, how am I going to connect for example 3 resistors in series? So, this is how, look at this picture, this is how I am going to connect the 3 resistors in case of series. So, how it can be connected? It can be connected one after the other. So, the first resistor, the end of the first resistor will be connected to the other end of the resistor, and the other end will be connected to the other end of the resistor. It keeps on goes. We can connect a number of resistors in a series like this. So, suppose if I connect the resistors, number of resistors in series, what will happen to the voltage and what is going to happen to the amount of current flowing through that, and also what will happen to the total resistance. That is what we are going to discuss. So, there are 3 laws are there, so which will express the meaning of, what will happen to the voltage, what will happen to the current, and as well as what will happen to the resistor. The first law, when 2 or more resistors are connected in series, the total resistance of the combination is equal to the algebraic sum of the individual resistance, which means when I connect all these 3 resistors, the total, what is the total resistance, the S stands for series, the total resistance will be equal to the algebraic sum of the individual resistance. So, this can be written as R1 plus R2 plus R3. So, I can connect a number of resistance. So, this statement can be expressed in this way. So, the total resistance will be the algebraic sum of the individual resistance. We will talk about what will happen to the current. The current flowing through each resistance is same, which means the current gets only one path. So, for example, if I am connecting the ammeter over here, you know very well the use of ammeter. Ammeter is used to measure the amount of current flowing through the circuit. So, if I connect the ammeter, I will be getting a reading of something. Let me take it as I. Suppose if I am connecting the ammeter over here, again I will be getting a reading of something. Let it take it as I1. And if I am connecting it here, I will be getting the other reading. Let it take it as I2. And if I am connecting it here, then I am getting the other reading of something. So, let it take it as I3. So, the total current, let it take it as IS. S stands for the series. So, the IS will be equal to the I1 and as well as I2 and as well as I3. So, the same amount of current flowing throughout the circuit. So, only in case of a series, the amount of current flowing through the circuit will be the same. Next, we will talk about the what will happen to the voltage. Potential difference is nothing but it is the voltage. The potential difference is different across different resistor. So, if I am connecting the voltmeter here, you know very well the use of voltmeter. Voltmeter is used to measure the potential difference across the ends of the conductor. Okay. So, if I am connecting the voltmeter, so I will let it take it as the reading of V1, and suppose if I am connecting the voltmeter here, let it take the reading as V2, and if I am connecting it here, let us take it as V3. Okay. So, this one will represent it as Vs. S stands for the series. So, voltage in case of series will be equal to the V1 plus V2 plus V3. So, the total voltage will be equal to the sum of the individual voltages. So, the total voltage will differ according to the resistance, it will be differing. Based on these, so far we have seen what will happen to the resistance, what will happen to the current, and as well as what will happen to the potential difference. Based on three equations, let us derive a formula. Yeah, we have seen about the law of resistances in case of series. Okay. So, we are going to derive an equation based on those laws. Okay. So, the first law, what it says, the total resistance will be equal to the algebraic sum of the individual resistance. So, how that can be represented? So, it can be represented as Rs, that is the total resistance in case of series will be equal to the individual resistance, that is R1 plus R2 plus R3, it keeps on goes. Okay. And what will happen to the amount of current flowing through that? That is the total I will be equal to the I1 and as well as I2 and as well as I3. Okay. Then what will happen to the potential difference? That is Vs is equal to V1 plus V2 plus V3. Okay. Now, we will take this as an equation 1, and according to Ohm's law, V is equal to IR. So, let us substitute this V is equal to IR in equation 1. So, IRS is equal to IR1 plus IR2 plus IR3. Okay. So, this equation, as I said, I is going to be same path, so same value. So, this equation will become Rs is equal to R1 plus R2 plus R3. So, this is the formula to find out the total resistance in case of series. By using this formula, let us do a problem. Look at this question. There are 3 resistors joined in series in a system having resistance equal to 10 ohm, 20 ohm and 30 ohm respectively. If the potential difference of the circuit is 240 volt, find the total resistance, that is we need to find out the total resistance and as well as the current. What is given? R1 is equal to 10 ohm, R2 is equal to 20 ohm, and R3 is equal to 30 ohm, and voltage is given as 240 voltage. We need to find out the total resistance and as well as the current. The total resistance formula is Rs equal to R1 plus R2 plus R3. We will substitute the values 10 plus 20 plus 30. So, this Rs is 60 ohm. We need to find out the current, then I is equal to V by R. Our V is 240 volt and our R is 60. In 6 table it goes 4 times. So, the total current is 4 ampere. So, in case of series, this is how we will find out the total resistance, and we will substitute the total resistance over there to find out the amount of current flowing through that. Let us see the advantages. The very first advantage of series is it is easier to switch on or off all the appliances connected together. Look at this picture. I have connected two bulbs in series. So, this switch will operate both the bulbs at the same time. So, it is easy to switch on and off both the appliances at the same time. Okay. And the next is safer as less current flows through the circuit, because when number of resistors or number of appliances connected in series, what will happen in case of series, the total resistance will become very greater. So, when resistance is more, we know that it will not allow the charges to flow. So, the amount of current flowing through that will be very, very less. So, that is why it in case of series, the less amount of current flows through that, so that it is very, very safe. It is used when hundreds and thousands of bulbs are used together. Okay. So, where do we usually use hundreds and thousands? Usually in decorative lights. So, in decorative lights, we need not to switch on or off individual lights separately, we can do together. So, in that case it is very useful, and also it allows very less amount of current through that. So, these are the decorative lights, and usually all the lights will be connected in case of series. So, when numerous thousands of lights are connected in series, it is very, very easy to operate. For example, in case of as they are connected in series, the resistance will be very, very high. So, the amount of current flowing through that will be very less. So, accidents, if suppose there is an accident, it can be it will not cause that much effect. We will talk about the disadvantages. If one electrical appliances stop working due to defect, then all the other appliances stop working. So, that is the very big disadvantage, because if it is a 2 bulbs or 3 bulbs connected in series, if one is got defect, and what will happen, both the bulbs will not glow. If it is a 2 bulbs, it is very easy to find out, but in case of thousands bulbs are connected, for example, in decorative lights, if 1000 bulbs are connected in series, if one bulb is got fused, it is very, very difficult to find out which bulb has got fused. Okay, that is the very big disadvantage. And all electrical appliances have only one switch, due to which they can be turned on off separately. So, all the 1000 bulbs together only we can on or off, we cannot on off separately, individual bulbs cannot be operated, that is the another disadvantage. Hope you would have understood the topic. We will see about the parallel in the next class. Thank you, children.